Lattice Semiconductor has a long history of innovation in programmable logic. We invented the GAL in 1985. In 1999, we acquired AMD's Vantis division. And today, we have the leading ultra-low power and low-cost CPLD, the ispMACH 4000 ZE. Lattice has shipped more than 1 billion devices over the last 10 years and 80 million in 2008 alone. Many designers choose Lattice because we have the right product for our customers' needs. For example, handheld consumer products, like this global positioning system, need ultra-low power and a tiny package. The ispMACH 4000 ZE has a 4x4mm 64-ball ultra-chip scale BGA package. All these consumer products must have a very small board area, ultra-low power, and ultra-low cost. ispMACH 4000 ZE meets all these design requirements with a static current of 10 microamps and a cost less than $1 US in volume production. ispMACH 4000 ZE solves many design problems. For example, in consumer products, like this camcorder, a low pin count microcontroller is typically used. The ispMACH 4000 ZE can provide general-purpose I/O expansion. At the same time, it can take care of voltage translation and interfacing between the LCD and MCU. And the ispMACH 4000 ZE I/Os are 5-volt tolerant. For other devices, like this PDA, the ispMACH 4000 ZE can monitor external activity from the keyboard, serial port, or memory card insertion and reduce processor interrupts. It can even save more system power by controlling the on, off, or standby status of other system components. The Lattice ispMACH 4000 ZE Pico development kit contains a compact board that allows users to see this amazing CPLD in action. The Pico board includes the ispMACH 4256 ZE device, 4 dip switches, an LCD display, and a Lattice Power 6 AT6 for accurate current measurements. In the power demo, the Power 6 AT6 measures the ispMACH 4256 ZE core and I/O currents and passes the value via I2C to the CPLD, where it is converted into the appropriate 7-segment decode for the display. The Pico board is factory pre-configured for this low-power demo. The dip switches determine what is being measured. We begin by setting the dip switches to measure the ispMACH 4256 ZE core current at 5 MHz. The display shows that the current is 800 microamps. We can change the dip setting to include a counter chain that drops the operating frequency to 1 Hz, and the new core current is reduced to 704 microamps. To measure the static current, we disable all functionality via the dip switches and measure across R35, a 50-ohm resistor on the board. The meter reads 0.5 millivolts, which translates to 10 microamps. Very impressive. Ultra-low power is essential for consumer products like this Kindle electronic book reader. The ispMACH 4000 ZE device can operate with a core voltage as low as 1.6 volts, lowering the static power even more. And PowerGuard allows designers to disable individual input pins when not necessary for lower dynamic power. The ispMACH 4000 ZE is also popular with handheld applications to provide general-purpose I/O expansion. It is very common for these devices to use low pin count microprocessors for cost and space considerations, but need additional pins to communicate with devices like displays. Here's a microcontroller connected to the ispMACH 4000 ZE with a compact 2-wire I2C bus over USB. ispMACH 4000 ZE has up to 112 user I/Os divided into 2 banks to support different voltage levels. ispMACH 4000 ZE has a compact I2C slave IP for easy communication with the processor. The Pico board demonstrates this powerful application by emulating the processor I2C master with the PicoView software interface running on a laptop. The Lattice Power 6 AT6 also contains an I2C slave so that it can too be controlled by the software for maximum flexibility. After loading the new design file for the ispMACH 4000 ZE, the display begins the default counter function. PicoView allows us to communicate with the ispMACH 4256 ZE and the Power 6 AT6 via I2C I/O expansion. On the left are the registers that we can read from to write to the ispMACH 4256 ZE CPLD. On the right are the sources we can choose for the Power 6 AT6 to measure. We now click on the Read button of the counter register and the Pico board display value appears. We can now send instructions to the Pico board by changing the counter register to 777, and the counter register is updated. And we see the new start value has been sent to the Pico board and it continues to count. The Pico board is a great tool for prototyping, and we also have 12 ispMACH 4000 ZE reference designs to accelerate the design process, including I2C bus master and slave, PCI target, pulse width modulation, SD-RAM controller, SPI bus controller, and UART. These are all free for customers to evaluate and use in their designs. The design tools for the ispMACH 4000ZE family are also available at no charge on the Lattice website. ispMACH 4000ZE is the ultra low-power, low-cost CPLD family, and with ultra-small packages, it is perfect for consumer applications like cell phones, global positioning systems, PDAs, personal audio equipment, digital cameras, video recorders, and set-top boxes. Go to the Lattice website to learn more at www.latticesemi.com/products/CPLD-SPLD.